A pleasant good morning to one and all. This is Aila Venkat Sitaram studying third year BTech at Satyabama University. Today I am here to explain about IoT internship at Emertxe Technologies. What I learned is first of all introduction of learning concepts. I learned about C programming in the first week, and further about that IoT internship, and then embedded systems and microcontrollers. And further week we learned about the project, its overview objective in the further slides. First of all, C programming. C programming is a general purpose language, even though it is applied and used efficiently in various specific domains. This is the basic structure of C programming. We had header files, preprops, directives, and this is the starting program. Topics I learned in C is data types. In data types, we learned about char, int, float, double, extra, and then modifiers and qualifiers, and then conditional and loops, and then operators, arrays and pointers, and then strings, functions, storage classes, and preprocessors. Uh, Coming to the Internet of Things, Internet of Things is the collection of network of connected devices, technology that facilitates communication between devices over the Internet. IoT system works through the real-time collection and exchange of data. We can see how IoT will change the world. It is in nowadays it is used in everywhere, in manufacturing, industries, home automations, and mobiles. One of these applications in IoT, we use it, we done project in home automation. Internet of Things applications in automobiles, manufacturing, logistic and transport for businesses, etc. And examples of IoT is we can do some projects in wearable health monitors and smart cars, smart buildings, and home automations. And then embedded systems. Embedded systems is nothing but it is a combination of software and hardware designed to do a specific task. They are low cost, low power consuming small computers embedded in other mechanical or electrical devices. Generally, they comprises a processor, power supply, memory, and communication ports. First embedded system main thing starts with a sensor. Sensor will sense the data and it will convert to the since the sensor data is in analog form, it converts to the digital form, which is understandable to the processor. And then we will convert to the again we will convert digital to analog since the in process we will take input as analog and giving output as analog. And then microcontroller has analog to digital block, digital to analog block, timers and counters, pulse width modulation, processor, memory, and input output ports. Microprocessors versus my RAM processors. The overview of the project is this project provides an IoT based home automation solution using Arduino Uno board in Pixim's lab simulator. Blink IoT mobile application is used to control the device remotely, control the lights, temperature of the home, and inflow and outflow of the water in the water tank. These are the basic things we usually see in homes. What is that we can control? We sometimes we will forget to off the garden lights or temperature to change the temperature of the home, inflow and outflow of the water in the tanks to save water. Connect the home appliances to the connect to the home appliances to the Arduino and integrate it with the Blink IoT app using Blink IoT, Blink Cloud. Control lights, temperature of home along with the level of water tank using mobile app. We can control the lights, temperature of home along with the level of water tank using mobile app. Obtain notification about the status of the home on the mobile. Using Blink app, we can see that the notification in the mobile. And then why home automation? Generally, people always don't stay at home. This brings the problem of home appliances not being monitored. The solution for this problem comes out to the home automation. Home automation enables people to control most of the devices remotely, such as volume of water present in the water tank, garden lights, temperature of the home. We use here is Arduino as a microcontroller and Blink app to control the temperature of the home, garden lights, and volume of the tank. And then what is micro? What is Arduino? Arduino is nothing but a microcontroller board based on Atmega 328P. It has 14 input output pins, 6 in 14 6 are PWM pins and 6 are analog input output pins. PWM pins are actually we can control from 0 to 255 pulse. Whereas other pins we can control as 0 and 1. 6 analog pins and 16 megahertz ceramic resonator, a USB connection and a power jack, ICP header and a reset button. It can be programmed using different IDE, Arduino IDE, integrated development environment used in this project. Arduino IDE supports C and C++ languages. PiximLab. PiximLab is an open source real-time emulator of development boards which integrates MPLAB XID or AVR GDB debugger. We used PiximLab as an virtual software in Arduino. It supports some Pixim microcontrollers and some SIM-AVR microcontrollers. It has integration with Arduino IDE for programming the board's microcontrollers. Blink IoT app configuration. We use Blink IoT to control this Arduino and this garden lights, water tank. In Blink IoT, we need to create a template and then add devices, and we will give options which as it is acting as a switch or a push button. Select and add data stream, create icon, include Blink library. LDR sensor. LDR sensor is a light detecting sensor that detects the light that falls upon it. The photoresistance in the light controlled variable resistor. The resistance of the photoresistor decreases with increasing in the incident. Means as the light increases, the resistor will decreases. The resistance will be decreases. So we can see that the resistance and the light intensity are inversely proportional. Means as light is more, the resistance will be less. The LED lights are connected to the LDR via the ADC. The ADC converts the analog input by the LDR into its equivalent digital form, which is then converted later by certain formula 0 to 255. As we before discussed that microcontroller uses only like, understand only digital signal. So we need to convert the analog input value that is coming from the LDR and converting to the digital form. And then garden light control. The properties of LDR is applied to accomplish the controlling of garden lights. During the day, the outdoor light is maximum, so the LDR sensor detects the light and the garden light is turned off. Whereas at night, the outdoor light is very low, so the LDR sensor detects the light and the light is turned off. Temperature sensor. The temperature sensor is recorded using LM35 sensor, which reads the analog value. The value is converted into binary value and later actually temperature is calculated using the obtained value of the voltage. The sensor does not require any external calibrations or trimming to provide accuracy. The output scale factor of the LM35 is 10 millivolts per instance. It provides an output voltage of 250 millivolts at 25 degrees Celsius. Temperature control system. The temperature control system consists of heating resistor, an LM35 temperature sensor, and a cooler. Analog value of the temperature is obtained from the temperature sensor LM35 and display it on the CLCD after converting it to the digital value using the ADC. Control the temperature of the system by turning on or off the heater and cooler through the Blink IoT mobile app. Water tank inlet and outlet valve control. Read the volume of the water in the tank through serial communication and display it on the CLCD. Control the volume of the water in the tank by controlling the inlet and outlet valve. By sending commands through serial communication and display the volume of the water in the tank on the CLCD and also in Blink IoT app. The tank refills itself when the outflow exceeds the threshold of minimum value 2000 liters and it stops filling when the tank is full at 3000 liters. Gives notification to the Blink IoT app. This is the simulation image of the project. We had LEDs and we had LCD and we had I2C with LCD and this is the Ethernet and this is the LDR sensor for garden lights, and this is the cooler and heater for temperature. Okay, thank you. This is the code I used in this home automation project. These are my templates, device name, and authentication token. And these are the included libraries, LDR, header file, main, serial tank, and temperature system. And this is the thing this is for operation of the cooler button. When cooler button is pressed, it should be on and then off. And for heater for heater button, for inlet valve pin and for outlet valve pin, and for updating of the temperature reading. And if heater is greater than 35 degrees Celsius, it will be off. And then handling of the tank, if it is less than, if it is less than 2000 or greater than, if it is greater than 2000 and or it is less than 2000 or off, the inlet valve will be on. And if it is equals to 3000 and still the inlet valve is on, and it will be off. And these are the initializations we did. And this is for the LCD and LCD set. This is for the displaying of the tank volume. First part of our project is about garden lighting, and this is the LDR sensor. And when the resistance is high, that means it is the night time, so the LEDs will glow. Since as we decrease the resistance, mm, the resistance will low, and it means that is the daytime, and LEDs will be off. See, the LEDs will be off. And then second part of our project is about temperature and cooling. This is the Blink IoT app in mobile. When I turn on the heater, the temperature will go till 35 degrees Celsius, and then if the temperature is greater than 35 degrees Celsius, the heater will turn off, and we will get the notification in the phone. Now we will see that now we will turn on the heater. Heat. As we see the temperature is increasing, it will reach the 35 degrees Celsius. It will, we can see in the LCD also, it is notifying as temperature is greater than 35 degrees Celsius, turning off the heater. Now we'll turn on the cooler. The cooler will be on. See, it is also displaying on the LCD. Cooler is off. We can see that the notification cooler temperature is normal, turning off the cooler. So since it is in the normal temperature, the cooler is off. This is the second part, and the third part is about the serial tank. The maximum level of water is 3000, and initially it was in the 3000 liters. The tank is full. Inlet valve inlet is off actually. Now when we on the inlet, when we on the outlet valve, the flow in the opposite direction. Now we'll on the outlet valve, the water will be out from the tank, and we can see that volume of the water is decreasing in the mobile as well as in the CLCD. As it is below 1500, the inlet will be on. you can visible that water level is less than 1500, water inflow is enabled. Now we cannot turn off the, if we turn off the outlet, the tank will be filled as usual. And if the tank is full, again we will get the notification in the mobile that the tank is full, so the inlet valve is off. Like this, we can feel that the water won't be waste, and we can operate it from anywhere, inlet valve, outlet valve.